Hey everyone, welcome back to Bug No Jutsu, your one-stop destination for mastering coding problems with clear and intuitive explanations. In today's video, we'll be solving an elegant yet tricky problem from LeetCode 1695, maximum erasure value. This problem is all about finding the best subarray with unique elements, and squeezing out the maximum possible score from it. We'll walk through the problem statement, understand it with a detailed example, break down the optimized solution, and wrap up with key insights and complexity analysis. Let's get right into it. The problem says, you're given an array of positive integers. You need to select a subarray where all elements are unique, no duplicates allowed, and return the maximum possible sum of any such subarray. Now, just to clarify, a subarray means a contiguous portion of the array. So you can't pick random elements from different places, they have to be in a continuous sequence. Your task is to find that one subarray with all unique numbers and the largest possible sum. Let's take an example. Input 4, 2, 4, 5, 6. We want to look at all possible subarrays that have unique elements only, and among them, find the one with the maximum sum. Let's walk through it step by step. Start from the beginning, the subarray 4 has a sum of 4. Then, 4, 2 has no duplicates, sum is 6. Next, 4, 2, 4, here the number 4 is repeated, so this one is invalid as a whole. Now we shift to 2, 4, 5, all elements are unique again, and the sum is 11. Even better, 2, 4, 5, 6, still unique, sum is 17. That's our answer, 17 is the largest sum of a subarray with all unique numbers. So, how do we efficiently find this in code? Let's break it down. To solve this efficiently, we use a sliding window approach with two pointers, let's call them I and j. These pointers represent the start and end of the current subarray we're looking at. We also maintain a running sum of the current subarray, and a dictionary or set to track which numbers are currently inside the window. Here's how it works. We start with both pointers at the beginning. As we move the j pointer forward, that is, extending the window, we add the number at position j to our running sum and also mark it as present in our dictionary. Now, if we ever encounter a duplicate, a number that's already in the current window, we shrink the window from the left by moving the I pointer forward. As we do that, we remove those left side numbers from both the running sum and the dictionary, until the duplicate is gone and our window has all unique elements again. At every step, we calculate the sum of the current window and keep track of the maximum sum seen so far. This approach ensures that we always maintain a valid window with unique elements, and we never have to recalculate the sum from scratch, we adjust it incrementally. So the sliding window grows and shrinks dynamically as needed, and at every valid position, we try to update the maximum score. Time complexity, O, n, each element is added and removed from the window at most once. So we're doing a linear pass through the array. Space complexity, O, n, we use extra space for the dictionary or set to keep track of elements in the current window. This is far better than a brute force approach which would be O, n superscript 2, if we checked all subarrays. Here are a few key insights that really make this solution elegant. First, using a sliding window lets us avoid redundant work, we don't need to restart for every subarray, we just slide across the array efficiently. Second, maintaining a running sum is much faster than recomputing it every time. And third, using a hash set or dictionary makes the lookups and deletions super fast, in constant time. Also, this problem is very similar in spirit to the longest substring without repeating characters, but instead of counting length, we're optimizing for sum. That analogy helps in applying familiar techniques in a different context. And that wraps up our deep dive into LeetCode 1695, maximum erasure value. If you found the explanation helpful, make sure to like the video, subscribe to the channel, and hit the bell icon so you never miss an intuitive breakdown of tough coding problems. Comment below if you want this problem explained using a different approach, or if you want to request a video on any specific topic. Thanks for watching, this is Bug No Jutsu, and I'll catch you in the next one. Until then, happy coding and keep solving.